Hello, we're up to part 9 of my book, The Philosophy of the Ananke by myself, Lance Gordon. Hope you at least subscribe and you can get a free copy if you look below this on the YouTube to email me. We are up to, let me get the book on the screen. We're up to Ananke and Chemistry in chapter 4, and we are up to page 54 if you're following along. Chemistry deals with the properties and transformations of materials. In other words, the way matter changes form. Chemists predict the conditions under which specific changes must occur. In essence, matter has been found to change form in an orderly, predictable way. Change is guided by law and not chance. Modern chemistry evolved from the 17th century, beginning with the study of gases in a vacuum under pressure. This led to a quantitative basis for chemical changes to include combustion and other reactions involving oxygen. Eventually, the evolution of chemical thought led man to interpret these changes in terms of atomic and molecular characteristics. The quantity of protons, electrons, and neutrons in a given atom seem to determine its unique properties. The arrangements of various types of atoms determine the nature of a given molecule, and the atomic arrangement and the shape of the molecules, along with bonding forces, natural vibrational frequencies, and the like, were found to determine the predictable behavior of matter with respect to its changing of form. The property of cohesiveness. Many chemical properties of matter have found to exist. A dominant characteristic is the one called cohesiveness. The atoms and ions of matter have a tendency to stick together. The two atoms that require an electron to be in balance are cemented together when an electron comes their way. The electron is shared by each atom in a kind of figure-8 orbit. This is covalent bonding, as in the case of the hydrogen molecule. Sometimes molecules have excess electrons. They are negatively charged. Sometimes molecules have a deficiency of electrons, thereby allowing the proton charge of their nuclei to dominate. They are positively charged. Sometimes these unbalanced molecules, these ions, randomly meet each other. They attract each other and bond together. This is called ionic bonding. Still cohesive. Molecules made up of several atoms require the property of shape, or acquire the property of shape. Atoms do not necessarily bond themselves at perpendicular angles. Various angles are employed depending on the atoms being joined and the bonding that is used. So the varying angular form of a given molecule produces the image of shape, of a shape. These shapes produce a lock and key effect due to chance motion. Due to the chance motion, the shapely molecules encounter one another. Appropriate ones, those by design, stick. They come together. They physically bond. In summary, cohesiveness seems to be a property of matter which tends to make things come together in a state of dynamic equilibrium. Chemistry defines dynamic equilibrium as, quote, one in which two opposing processes are going on simultaneously at the same rate. The effect is no change. Actually, most of the time, with the dynamic equilibrium, the opposing forces kind of struggle with each other, and you get more or less a vibration, one way than the other, So it's more of a little vibration that takes place in terms of the dynamic equilibrium. In other words, the shared electron in covalent bonding attracted one atom, then moved away from it in order to attract the other atom. So electrical attraction is being opposed by kinetic motion. These forces are in balance as experienced by the electron. It never is captured by either atom, nor is it free to wander off into empty space. In turn, this balance of force on the electron has an equal and opposite reaction on the atoms. Each atom is pulled toward the electron every other instant of time. Conversely, each atom tries to wander off into empty space every other instant of time. Therefore, a state of dynamic equilibrium is achieved. For practical purposes, no energy is lost from this closed system. It is merely transformed. This process is therefore perpetual as long as energy does not enter or leave the system. This process, this dynamic equilibrium that emerges as the result of opposing forces to the wandering nature of particles could go on forever. This cohesiveness, this tendency towards dynamic equilibrium, is Ananke, as you recall. The property of orderliness. Not only is matter found to be cohesive, but it is found to exist in highly ordered states. What is order? Is it not the repetition of some fundamental unit of form? Yep, it is if you think about it. Crystallinity is a perfect example of pattern repetition to produce the image of orderliness. The atoms in many substances arrange themselves with an enormous degree of order. But what is the image of orderliness reflecting? Is it not reflecting a common influence that all the particles must obey? In this manner, they would all go with the same flow. They would appear orderly. In the case of particles, the flow is merely a force, or a group of forces that act on the particles in the same manner. Forces and law prevail. All are influenced to obey. This crystalline order is not likely by chance alone. It is due to the atomic and molecular forces that act in an orderly, consistent manner. In fact, statistically speaking, order should not exist. Even if forces exist, they should not act in an orderly manner by chance alone. For example, let us take a 4x4 box that contains 16 compartments. 4 times 4 is 16. We can place 4 balls in any configuration that we desire. Through mathematics, we can determine there are 1,820 possible arrangements. Would you say that 50% would appear orderly? How about 25%, 10%? Not even 5% are crystalline in appearance. The chance of order occurring by randomness alone, without the help of the universal forces, is less than 3%. Therefore, in the absence of external cohesive forces, we would expect to find a universe of pure disorder. Of course, there are more than 16 compartments for every 4 particles in the cosmos. The statistical chance of order would be far less than 3%. Disorder should prevail. The odds are on its side. We call this tendency for disorder and its resulting eventual unavailable energy the tendency towards entropy. All things in the universe have a statistical tendency towards disorder. If unopposed, this force of disorder, wandering, diffusion, and chaos would prevail. It's likely. This is definitely not the case. Entropy is opposed by the forces of order. The result of this battle is a highly unlikely degree of pattern repetition. Gases condense to form liquids. Liquids condense to form solids. Solids orbit other solids. Crystallinity occurs. Therefore, we can view the forces in our universe as tending to control chaos and its resulting entropy. Chaos is brought back into a state of dynamic equilibrium. Entropy is minimized. Energy is utilized towards creativity. Very important concept. Random motion and negative change away from dynamic equilibrium is bound by the cohesive forces that may be strained but can never be broken. These forces act upon the change in a most efficient manner in order to bring about a state of balance. This is still the formula of the Ananke. The property of suspension. Matter is found to be composed mostly of empty space. That is to say, the atoms and molecules are suspended in the ether, or what they called an ether, of the cosmos. They are held there by virtue of the interactive forces which simultaneously separate and bond the molecular groupings. Not only are the atomic structures separated by a lot of space, they are composed mostly of emptiness themselves. The electron cloud shell at the outer edges of an atom is 100,000 times larger than the nucleus itself. Since 99% of the mass of the atom lies in the nucleus, it should become obvious that the atom's internal volume is mostly composed of non-mass or space. This can be viewed as similar to a micro solar system, where planets and satellites are both separated from each other while at the same time bonded to each other in an orderly way. One source of evidence of the amount of space in matter can be viewed from the perspective of the density of certain stars in our universe. These stars have compressed their matter to the point where some of the empty space has been eliminated. They are extremely hot and dense. They are called white dwarfs. You may ask, how dense are they? They are so dense that you could put 400,000 pounds of the stuff in a quart milk container. That's how dense they are, and that's pretty dense. Put that in your shopping wagon. So the matter of the universe could be considered could be condensed to a relatively small sphere of mass if it only were compressed by the cohesive forces to a sufficient degree. But what forces could possibly do this job? Certainly gravity cannot do it alone. The answer lies in the efficient force system of our universe. Remember we said efficiency was part of this Ananke. When objects are far apart, 1 inch to 1 million to millions of miles, gravity dominates. When objects are close together, the electrical and magnetic forces dominate their interactions. When particles are squeezed so tightly that the nuclear electron clouds intermingle, then the nuclear forces dominate and overcome the gravitational electromagnetic influences. So different forces dominate the ever-changing situation based on the space separation between the particles in question. With each cohesive compression, a new, stronger, more appropriate force takes over. This is similar to shifting gears in order to reach a speed of 60 miles per hour. It is more efficient to use the first gear up to 15 miles per hour. The second gear should be used from 15 to 35, the third gear to 55, and the fourth gear for cruising after 55 miles per hour. It is more efficient to have quantized forces than to have only one force do the job. So the forces could theoretically squeeze out the large distances by the use of gravity, the medium distances by the use of electromagnetic interactions, and the micro distances by the use of nuclear bonding. Therefore, we can view the universe as capable of opposing entropy by the use of these cohesive forces. It is capable of squeezing the empty space between particles to an enormous degree. In essence, entropy creates interparticular space, and the universe is capable of reversing this situation. It not only reverses this process, it does it efficiently. Using the above mechanism, we can now understand how all the matter in the cosmos could have been compressed into a tight little ball. We can visualize an original primal sphere of matter, more dense than a dwarf star. This can be viewed as the original form of the universe at one point in its cycle. Or, as scientists have found, they extrapolate and think it might be a point, but we can discuss this later on in the book in some updates. The property of differing forms. Matter occurs in various states, ranging from low cohesiveness and random patterns to extreme order and high bonding. Examples include gases at the low end, liquids in the intermediate class, and crystalline solids at the most structured matter of them all. Changes from one state to another can be explained by the rearrangement of atoms and the transformation of energy. The atoms merely change position in order to produce the observed chemical properties of the created substance under consideration. Some reactions may be exothermic, they give up heat. Some may be endothermic, they absorb heat. In either case, energy is transformed from heat to mass. Remember, energy is not created nor destroyed. It is merely transformed and transmitted. The total energy in a closed system remains constant forever. The conversion between heat energy and mass is given by Einstein's famous formula, E equals mc squared. E is energy, m is mass, and c is the speed of light. When manipulating this formula, it becomes apparent that a little mass goes a long way. Mass is the most dense form of potential energy known to man. The universe has done an excellent job at converting the original kinetic energy, motion energy, from the primal explosion into the potential energy called mass. In summary, chemical change can be reduced to the controlled motion and rearrangement of atoms. The chemical reactions absorb or deliver energy, resulting in minute mass conversions into the substances involved. First law of thermodynamics. This law states that we cannot produce a machine that does work without replacing this energy. In other words, a perpetual energy machine cannot exist. We cannot create energy out of nothingness. We can transform energy from gasoline to motion. We can transmit energy from Niagara Falls, for example, to our homes by the use of electric generators. We can resonate energy and stimulate our radios and televisions to produce numerous stations and frequency bands, but we cannot create energy. The best we can hope for is a perpetual motion machine. This is theoretically possible in a closed system where no energy can escape. The motion would undulate between kinetic energy and various forms of potential energy. For example, let us picture a ball in a spring that is suspended in a closed system container. The spring is ideal, it never wears out. No energy enters the box and none can escape from it. We magically start the ball moving. It swings to one side, thereby stretching the spring to the max. It stops momentarily. It reverses direction, gaining speed with time until its motion is reversed once more. This process can continue forever. It is perpetual motion. It is possible in a closed system. In practice, there are no closed systems. Energy escapes, the motion slows down, the pendulum stops. There are no closed systems except one, perhaps, and that is the universe. Ananke geology. Let me just check the time of how we're doing. It's only 16 minutes. So we're at 16 minutes. Geology is concerned with the large physical changes that take place on the earth and on the heavenly bodies, on other heavenly bodies. From the primal beginnings, approximately 6 billion years ago, the earth has gone through an orderly process that has resulted in what we see today. The mountains, seas, oceans, and deserts have evolved from the primordial gases which condensed into the quasi-solid mass we call Earth. The Earth is continuously in a state of controlled change. Volcanoes and earthquakes release pressure from the constantly moving continents and ocean basins that make up our outer shell, the Earth's crust. This motion produces enormous stress, which sometimes results in a crunching or buckling effect when it encounters a trough. The result of this compression is a mountain range. In turn, the opposing forces of erosion, with the help of gravity, tend to bring these imbalances back to equilibrium again. They tend to make the Earth round, all particles being an equal distance from the center. More precisely, since the Earth rotates, an elliptical shape is pursued as the least energy dynamic equilibrium solution, which of course is still the Ananke. These processes work quite well. From outer space, the world appears like a uniform, peaceful sphere that is suspended in the eternal void. There can be no doubt that from a geologic point of view, the forces of the Earth tend to produce an equilibrium condition in the midst of constant change. The composition and dynamics of the Earth. The surface of the Earth is composed of more than 2,000 minerals. Each has a unique crystalline structure that distinguishes it from the other compounds. Pattern repetition, and therefore order, is the rule with respect to the internal atomic arrangements within. The color, shape, and size of any given mineral may vary, but the internal orderly pattern remains the same. These minerals vary in hardness, density, cleavage properties, striation patterns, and the like. So the surface is not homogeneous in nature. The minerals vary in hardness. The mountains are composed of igneous, sedimentary, and metamorphic rock. Therefore, the opposing forces act unevenly on the newly created mountain ranges. Intricate patterns results. Valleys, hills, mountains, peaks, and the like are formed. As was suggested above, mountain ranges are inevitable due to the motion of the Earth's crust. However, the opposing forces of erosion start to work. Glaciers, heating and cooling, wind and rain, along with the help of gravity, tend to flatten the undulating surface in order to produce equilibrium again. These forces operate in a slow, gradual, least destructive manner. They do not blast the mountains off the face of the Earth, off the face of the planet. They gradually erode the disturbance until it is no more. This is still the pattern of Ananke. But why is the Earth still changing? After 6 billion years, you would think that it would settle down to a state of eternal bliss. What's happening? Why is negative change inevitable? The Earth is changing because it is still cooling from its origin. The Earth is not uniformly at the same temperature. It is not even totally solid. Heat is distributed in an uneven manner throughout its volume. But if the original gas is cooled and condensed, then where did the heat come from? Two sources are available. Firstly, the pressure of compression squeezes molecules closer together, so they collide more often. Friction, and therefore heat, results. It is an obvious realization. Just rub your hands together, and you will create heat from motion. The second explanation is more complicated. An example will enlighten us. When water boils, it is at a temperature of 212 degrees Fahrenheit. As you add more heat by the gas flame, where does the energy go? It cannot disappear. Energy cannot be created nor destroyed. It is transformed into the steam, but the liquid remains at 212 degrees. And the steam does too, right above that liquid, until it expands and then cools down. We still should ask, where did the heat energy goes? The answer is relatively simple, but a little confusing. It went into creating what's called the change of state of matter. The transformation of the liquid water to the gas of steam at the same temperature of 212 degrees does not come free of charge. Energy is used to perform the task. Evaporation takes heat, which is energy, from the object it comes from. On a dry, windy, hot day, you can develop a chill when you perspire. Heat has been taken from your skin. So the change of state from order to increased disorder necessarily absorbs energy or heat. Solids become liquids, give up heat to the liquid form. Solids that becoming liquids give up heat to the liquid form. Liquids becoming gases give up heat to the gas form. The form of gas now, we're not talking about temperature. All of this happens without a rise in temperature in the resulting product. The objects giving up the heat do cool down. The objects absorbing the heat do not heat up. The energy is stored by virtue of the new state of matter, which is really confusing. Perhaps it is stored as an increase in mass. We don't really know. Nonetheless, it is stored as potential heat, called latent heat. Therefore, the reverse process also must be true. When gases cool, they condense to form liquids, but the state transformation delivers heat as described above. When liquids cool, they produce solids such as ice. During this transformation, heat is released. So the property of state of matter slows down the cooling or heating process. If something is cooling, then heat will be released periodically when a state of change in the matter occurs. Conversely, if something is heating rapidly, then cooling will occur periodically as states of change are performed. This property of the universe is absolutely astonishing. This process actually slows down the rate of change as far as temperature is concerned. Temperature is simply an indication of atomic motion, so it actually controls the internal motion of the matter by these opposing processes. It does not allow total chaos to prevail. It actively opposes the change from the equilibrium condition. Think about that. So, to answer our original question, the condensing gases of the primordial universe resulted in objects that had to heat up due to the change in state phenomena, and the frictional forces produced by the resulting pressure. The resulting temperature depended on the size of the object condensing and the rate of matter transformation. Larger bodies tended to be higher in temperature. Smaller bodies tended to be cooler. Perhaps that is why the Earth is cooler than the Sun. Sedimentary rock and relative time. Erosion and time produces soil and pebbles, among other things. These substances are deposited by running water and wave action. The deposits produce a kind of layering effect since dry and wet spells alternate. Wet spells deposit the material. Dry spells allow it to compress itself. As discussed above, compression yields heat. The heating of these elements produces a layer of rock called sedimentary rock. Along with minerals, creatures, and plants may be deposited. Wooden bones may be buried in the layers. Plant impressions may exist as the only remains after decomposition. Since sedimentary rock is layered sequentially in time, we can tell the relative ages of the creatures within. That is to say, the bottom layers are older than the top layers of rock. The bottom layers were laid down first, the top layers were laid down last. Creatures that were found in the bottom layers have to be older than the creatures found in the top layers. It just makes common sense. So sedimentary rock structures are very useful in determining the relative time of certain geological events. Creatures in abundance in the bottom layers could be found to be extinct in the upper layers. In this manner, geologists were able to determine the evolution of the creatures and the plant life on this earth. By the 1800s, there was no doubt that some creatures lived before others. The geologists found evidence of dinosaurs and the like, which no longer exist today. Many creatures today did not apparently exist in the past. The earliest layers, the lowest layers, had no evidence of mammals or reptiles. Only oceanic plants and single-celled organisms were found. But how did this evolution, this change occur? How long ago did these events take place? Were the bottom layers 6,000 or 6 billion years old? How can we date the rocks? Let me get to the next page. Radioactive decay and the absolute dating of events. I'm just going to check the time right now. 25, we're all close. We'll do one more section maybe. Nuclei of certain atoms and certain elements decay. They emit particles and energy, which in turn changes their mass, consequently resulting in new atoms. This process is known as radioactivity. For example, uranium-238 decays into helium, lead, and energy, radiation. The process of radioactive decay is intriguing. Each atom seems to have an equal probability of decaying spontaneously over some period of time. There is a 50-50 chance that an atom of U-238 will decay over a mere 4.5 billion years, and the 50-50 chance period of time is called the half-life of the substance. In other words, we would expect 50% of the uranium to be converted into lead in a given rock over 4.5 billion years. Since lead will not decay, the remaining uranium could decay further. In another 4.5 billion years, 50% of the remaining uranium would decay into lead as well. This would result in a rock containing 75% lead, 25% uranium. So the proportion of lead to uranium in it is a dead giveaway for the age of the rock. By this method, geologists have determined the oldest rocks are in the neighborhood of 3 to 4 billion years old. Since the Earth was formed before the first rocks condensed, the Earth must be older than 3 to 4 billion years. In fact, it has been deduced the Earth is more like 6 billion years old. And that could have changed since 1985. This process is excellent for igneous rock formations. But what about sedimentary? You have to use something that forms at the time of the layering. It not only must form, it must decay. Fortunately for us, some sandstones and shales contain glauconite. It forms at the time of sedimentary deposition. It contains radioactive potassium, which starts decaying when the mineral is formed. Thus, sedimentary rock layers can be dated. Creatures buried within can be assumed to be approximately the age that is implied by the proportion of the decayed material. In this manner, geologists have dated the evolution of creatures and plant life on this earth. And I think I'll stop there. We're still in the same section. We're up to the progression of life. So let me see where we are. Yeah, 28 minutes. So I'll see you next time in the next part. Take care.